Good afternoon and welcome to Fish Hawk Live and the Great Lakes Fishing Podcast. We usually discuss target species like trout and salmon and how to catch them, but today we're going to do something a little different. We're talking sea lampreys with Ross Shaw from the Great Lakes Fishery Commission. Ross, welcome to the show.
Thanks so much for having me, Chris. I'm happy to be here.
Ross, first off, can you tell us a little bit about the sea lamprey? I read on the Great Lakes Fishery Commission website that the species has been around for more than 340 million years and has survived more than 4 major extinction events. That's pretty astounding. What makes this creature so adaptable?
So that's really a great point you make. So these guys are their lineage dates back 340 million years. So even though sea lampreys are fish, they aren't exactly what you would think of when you think of a stereotypical fish. So and it looks almost kind of like a water snake combined with almost an eel. But unlike most fish, these guys don't have any paired fins. They don't have bony jaws. In fact, they're all cartilaginous. And so that that evolutionarily early adaptations in their body is what makes them such an adaptable species. So these guys were native to the Atlantic Ocean and then invaded through the man-made shipping canals in the early 1800s. And then they were only in Lake Ontario for a while because they couldn't get past Niagara Falls. But once the Welland Canal was widened and deepened in the early 1900s, that gave them an easy path right around the falls and essentially was open season on many of the Great Lakes commercial, recreational, and tribal important fisheries. So lake trout, whitefish, and pretty much anything that the sea lampreys could get their mouths on.
Yeah, tell me a little bit about that. Once they were able to kind of clear those falls, how fast did that spread occur? How did that happen?
So they were first. Obviously they geographically, so they were first in Lake Erie, but the problem wasn't really noticed because the fishery wasn't as prominent, and I believe that was primarily due to the industry that was along the waters there. So there wasn't a whole lot of great habitat for the sea lampreys to establish there, and it wasn't until they actually reached Lake Huron and Lake Michigan where they really started to do some damage, and that people started sounding the alarm per se on the sea lamprey invasion. And it was by 1938 that sea lampreys had actually reached Lake Superior, and the problem had come to almost nearly a peak. And at that point, the commercial and recreational and tribal fishers, as well as coastal communities that depended on these fishing operations, really started sounding the alarm and talking to elected representatives to get both the United States and Canada to come together to deal with the sea lamprey problem, because sea lampreys obviously did not obey these boundaries, these predetermined boundaries. So there's six or seven Great Lakes U.S. states, as well as 2 Canadian provinces that surround the Great Lakes Basin, and many different tribal nations. So there are many different jurisdictions around the Great Lakes, and because the sea lamprey problem was so pervasive and caused such a disruption to day-to-day life, both the governments of the United States and Canada realized that they would have to come together. They weren't going to be able to handle this piecemeal like they previously did, having each jurisdiction handle things on their own and not communicating with other jurisdictions. They realized that they really needed to come together and form an entity to work across the borders, and that's when the Great Lakes Fishery Commission was established. Was in 1955, when both the U.S. and Canada finally came together to tackle the sea lamprey problem.
It's been almost 70 years since that happened, Ross. I think people today, they know that they're there and they know that they affect things, but can you try to kind of paint the picture of what it was like at that time in the 40s and 50s, how much of an effect it is? Put some numbers to that.
Absolutely, yeah. So one of the sea lamprey's favorite prey species, the lake trout, to put some numbers to this, annual commercial lake trout catches in Lake Huron in Michigan, they were around 5 million kilograms in the 1940s, and that dropped to nearly 0 in the late 1950s. And the lake trout, in fact, were almost extirpated or eliminated from 4 out of the 5 Great Lakes. So every lake except Lake Superior. And the only reason they were still in Lake Superior is because that's the last lake that they invaded, but also the first lake where sea lamprey control was started. So, I mean, lake trout, lake whitefish, all these enormously important commercial and recreational fisheries were absolutely decimated. And of course, the associated coastal communities that depended on the tourism that needed got money from marinas, other things like that. They were, of course, also decimated as well.
All right. You talked about the different lakes that they spread to, obviously, into all of the lakes. Is there something about some of the lakes that make it kind of more susceptible to sea lampreys? Maybe Lake Superior with deeper, colder temperatures, is it less susceptible? How does that work?
So I wouldn't say, as far as limnologically, that there's any ability. I guess, like I touched on earlier, if when they first invaded Lake Erie, for example, had significant pollution. And so because the water and stream quality was degraded, they didn't have good spawning habitat. So sea lampreys, when they go to spawn, they look for a very specific substrate, a rocky substrate. Then that's what they use to actually build their nests. So you could go and say that, yeah, if they don't have that specific substrate, they don't have good stream quality, that would affect it. You see with the environmental movement that started, with the Great Lakes Water or the Water Quality Act and improving stream health. Okay, that's great that the stream health is improving, but you also see, because that stream health is improving and making good habitat for sea lampreys could also invade there. So by improving stream habitat, you also are, on the other hand, improving sea lamprey spawning habitat too. So you could look at it in that sense that by improving stream habitat, sea lampreys can also proliferate in that newly improved habitat too.
Well, that's a great point you bring up, and that's something that I wanted to ask you about next. What is the life cycle of a sea lamprey? How does that work? How long do they live, and what are the different stages?
Yeah, so it's hard to put an exact number on on how long a sea lamprey will live, and that's primarily because let's go to the life cycle first. So they hatch from their eggs, and then they go into what we call larvae or amicetes. So that's when these guys are really small, about the size of your, there you go, very small, about the size of your pinky, maybe even smaller. And so at that point, what they're going to do is swim downstream and bury into the stream bed, and they're actually going to filter feed. So at this point, they're essentially harmless. So they're just buried in the stream bed, filter feeding on phytoplankton, zooplankton, and other organic material in the environment. And they're going to be in that stage from anywhere from 3 to 5, and sometimes even up to as much as 10 years. So that's kind of, at that stage, that really kind of throws a wrench into the calculation of, how long do sea lampreys live? That is the stage that primarily affects its lifespan the most. But after they spend that time in that larval stage, what they'll do is actually metamorphose. So that's when they're going to develop eyes and that sucker mouth that everyone is so familiar with. And that's when they'll swim downstream and begin their parasitic feeding phase. So that's when they're going to go and do their damage. They're going to go out into the lakes and start feeding on fish. So each sea lamprey in that 12 to 18 months of their feeding phase is going to kill about 40 pounds of Great Lakes fish. And after they're done feeding on fish, they turn into what we call the spawning adult, and their digestive tract will actually shut down, and they'll be focused on spawning and spawning only. So what they're going to do is find a stream that has a good spawning habitat, and actually how they find that is super interesting. So the larvae, after they hatch and are burying in the stream bed, they actually excrete what's called a pheromone, or it's this natural scent that they excrete, and it actually flows down the river out into the lakes. And that's how sea lampreys in part determine which streams they want to go back up to spawn. By smelling those freshly hatched larvae, they can determine that, there's some good spawning habitat up there. So once they find a good stream to go up, they'll swim upstream. And then, as I mentioned, they make these rocky horseshoe-shaped nests. And so once they have made that nest, they'll actually intertwine. One will latch on top of each other, and then the bottom one will latch onto a rock. They'll intertwine, wriggle, and then they will release their sperm and eggs downstream onto that rocky horseshoe-shaped nest, and so that's when the eggs will hatch. And then the sea lampreys will actually die after they spawn, so they kind of are similar to a salmon in that way. And so that's part of the reason that once they're done feeding, they are focused on spawning and spawning only, and that's because that's their essentially goal in life. Is once they're done feeding, they have one thing and one thing only. It's going to be spawning and dying. So all said and done, we estimate it's about 2 years on top of however long they spend in that larval or amosete phase. So that can be as little as 5 years to as many as 12 years.
Very interesting. One of the other things we were talking about is that they're native to the Atlantic Ocean, and the fish in the Atlantic Ocean have kind of built almost a defense to sea lamprey attacks that Great Lakes fish don't have. Can you tell me a little bit about how they really affect fish when they feed on them?
Yeah, absolutely. So what the sea lamprey will do is, if you see its mouth, it has over 150 razor sharp teeth and a sucker mouth. So they use that sucker mouth to actually latch onto the side of the fish. And it has a suction cup around the outside of his mouth. So it latches on, it uses those over 150 razor sharp teeth to dig into the side of the fish's flesh. And then in the center of the mouth here, you can see what's called the rasping tongue. And so that's what really does the damage. So once they're attached onto that fish, they use that rasping tongue to gnaw and bore a hole through that fish's scales and into its flesh. And once it's created that hole and the blood starts flowing, it's actually going to excrete an anticoagulant to prevent the blood essentially from stopping. And so that fish will sit there, or the sea lamprey rather, will sit on that fish and feed on it for essentially as long as it wants. So most of the time, a sea lamprey will kill that fish that it's on. But as you can see from this photo here, if that fish does survive the sea lamprey attack, the sea lamprey will leave a really nasty wound. And so that wound will either oftentimes become infected and cause the fish to die, or it'll make the fish more susceptible to predation. So most of the time, if a fish is attacked by a sea lamprey, it's more often than not going to succumb to its wounds and die. So we estimate about 6 out of every 7 fish that are attacked by sea lamprey do eventually die. So these guys are very lethal. And you had mentioned, the Atlantic population, and so part of the reason they're so problematic here in the Great Lakes is because out in the Atlantic Ocean, these guys have co-evolved with the much larger fish. So you think about they're feeding on fish on the scale the size of like a tuna, or say like a shark. So these are significantly larger fish, and those smaller wounds that they're leaving on the fish, they aren't actually going to be killing that fish. It's more of kind of like a leech, where it'll drink your blood and it'll come unlatched. It gets what it needs. It drinks your blood, but then you're left essentially harmless. You have the wound, but the wound heals over. But when it's in the Great Lakes, you think about the fish that it's feeding on. So you think about like a lake trout or a whitefish. Those fish are magnitudes of times smaller than a tuna and have not co-evolved with this sea lamprey that's from the Atlantic Ocean. So that wound that it normally wouldn't be a problem on an ocean-going fish like a tuna is going to be much more problematic and cause much higher mortality on the native fish here in the Great Lakes compared to those in the Atlantic Ocean.
We're visiting with Ross Shaw today from the Great Lakes Fishery Commission. We're talking sea lampreys, and if you have any questions for Ross, whether you're on YouTube or on Facebook, go ahead and put those in the comments, and we'll get them to Ross. Ross, now you've been talking about salmon, you've been talking about lake trout, whitefish. What other, and I showed a picture of brown trout, what other species, is every fish in the Great Lakes susceptible to sea lamprey attacks?
Yeah, and so that's part of the reason sea lampreys are so destructive is they really are willing to eat just about anything that they can get their sucker mouths on. So scientists have actually proven that sea lampreys will have a preference for lake trout, but in the absence of those preferred prey species, they will attach to anything. So they have attached and killed fish as large as sturgeon to things as small as perch, bass, walleye. So they really don't have a preference. They just want something that has blood, and if they can get their mouths on them, they're happy with it. So
All right, we're starting to get a question here. Here's one from Captain Jamie Shane, Sporty 2 Charters out of Erio, Ontario. Jamie wants to know, how big can they get?
Yeah, so great question. So on average, sea lamprey will be about a foot and a half long. But in the Atlantic Ocean, where they're feeding on much larger fish, they'll actually get about 2 feet big. So they do get significantly bigger in the Atlantic Ocean. But yeah, here in the Great Lakes, about a foot and a half long. And then, yeah.
All right, my son wants to know, can they attack humans if we're swimming in the Great Lakes?
That is probably our most asked question, and I am happy to report that you can swim without fear. So sea lampreys will only attack warm-blooded creatures. They will only attack cold-blooded creatures. So fish, as we know, are cold-blooded creatures, and so sea lampreys can detect what type of blood a particular organism has, and they will only attach to cold-blooded creatures. So if there have been stories, back during the peak invasions of the early 1900s, supposedly there was a swimmer, a woman who swam across Lake Ontario, and the news headline was, "A woman emerges from Lake Ontario covered in lampreys." And while that probably did happen, I'd say more likely cause of them attaching to that particular person was that they were more hitching along for the ride than actually drinking that person's blood, just because, as I said, they are not interested in warm blood. And I'm going to go turn on the lights here.
Now Ross is in the witness protection program as the lights go out, and it's interesting. We've had one other guest that happened to him, and that person's name was Ross too. Something about Ross and lights.
Oh yeah.
You're still dark, Ross, but here's another question, and this is a good one. We've been talking about Great Lakes here so far today, but Joe Chase wants to know how they're being dealt with in the Finger Lakes. I'm assuming he's talking about the Finger Lakes in New York.
Great question. Yeah. So we actually have a whole entire division devoted to treating sea lampreys over in the Finger Lakes. So that is our folks at the U.S. Fish and Wildlife Service out in Vermont. So we have a dedicated source of funding specifically to fighting sea lampreys in the Finger Lakes. So we do have our partners at the U.S. Fish and Wildlife Service out there treating sea lampreys almost every year.
All right, Ross, that actually leads us to my next question, and that is, what are we doing about them? How do we control sea lampreys?
Yeah, great question. So we use primarily 2 control methods. And so that first one is what we call lampricides. So what this is, it's a selective toxicant that we apply to streams where we know that there are high concentrations of those larval lampreys. So we have our partner agencies at the U.S. Fish and Wildlife Service here in the States, as well as Department of Fisheries and Oceans over in Canada. Those are going to be our partner agencies who are actually going out and conducting the field work. So what they'll do is they'll send out agents with electro fishing backpacks. And what that is, it kind of look like Ghostbusters. And what that is they have these little electric paddles that they go out into streams. And then what they'll do is they'll actually tickle the sea lamprey out of the stream bed. And then depending on how many larval lampreys they find, they can use that data to extrapolate and determine the relative abundance of larval lampreys in that stream. And then once we determine, okay, which specific stream has the highest concentrations of lampreys, what we'll do is we'll decide, okay, this will be a good candidate for a lampricide treatment. And so once we're ready to apply this lampricide, what we do is we find the stream, and then we'll actually go up essentially as far up the stream as the sea lampreys can get. So most oftentimes this is the first barrier up the stream. So whether it's a purpose-built dam to actually block sea lampreys, or something like a hydroelectric dam. But anyways, we'll go up to where we know they will not be able to get above, and then we'll just treat the stream down from there. So we have these lampricides. So what we'll do is we'll apply it at a very small concentration. You're looking on the order of parts 3 to 5 to 7 parts per million, like very, very small amounts. And what that is, it's applied as a liquid via a perforated tube across the stream. We'll also go into little streams and creeks and tributaries and also apply different forms of this lampricide, sometimes in the form of just blocks, and just put those in these slow running streams to let them slowly dissipate, because we want to make sure we get every possible way into that river, in and out of that river, to make sure there are no larval lampreys that are going to be escaping this lampricide treatment. So with this lampricide, it is by far our most effective and efficient control method, but the downside to this is that it is extremely expensive. So as I mentioned, we do have to be very specific and very strategic about where we're going to apply this lampricides. And then the other control method that we use in concert with lampricides is barriers. So as I mentioned, these can be barriers that are purposely built to block sea lampreys, or they could be any barriers that have a different function, but also by chance do happen to block sea lampreys. And so, as I mentioned, the sea lampreys cannot get above the barriers. So the barriers actually help us limit the amount of stream miles that we actually have to apply that lampricide in. And you also showed that picture of a trap. So traps are a method we use to remove sea lampreys from streams. However, because the traps, they are not as efficient, they aren't so efficient that we classify them as a control method. So primarily what we use traps for is for assessment purposes. So what we'll do is we'll put these traps oftentimes at the base of dams and other barriers. And then based on how many lampreys we get when they come upstream to spawn, we can use that to help us determine the size of the sea lamprey populations. So those lampricides and barriers are our two primary control methods, but we as the Fishery Commission are investing a substantial amount of money into research into other control methods. So for example, one interesting possible control method that is being explored is what we call pheromones. So I mentioned that pheromone that the larvae excrete to tell spawning sea lamprey that this is a suitable spawning habitat. Some of our scientists have actually determined that sea lampreys have what we call an alarm cue. So that is what we call a repellent pheromone. So that pheromone that I talked about that the larvae excrete, that's what we call an attractant pheromone, otherwise or known. So the larvae will excrete it, and then the lampreys come towards it, whereas this alarm cue is what we call the repellent pheromone. So that is, as the name implies, repels the sea lampreys. So that's excreted by dead or dying sea lampreys to tell them to, get out of here. You don't really want to be here. There's a predator or something else that could put you in danger nearby. And so what some of this research is looking into is seeing if there's ways where we can use those attractant and repellent pheromones to improve that trapping efficiency. Because as I mentioned, currently trapping isn't efficient enough to the point where it's making a substantial indent on the sea lamprey populations. So what the idea is with this pheromone is, say we have a fork in a river, and this is really good spawning habitat, and this side is a trap. So we don't want them to go to the good spawning habitat, so we might apply that repellent pheromone in that side of the creek, and then put the attractant pheromone on the other side of the creek to help encourage them to get into the trap and increase that trapping efficiency. So it's super, super interesting stuff, and our researchers are doing great work, and it'll be very interesting to see how sea lamprey control evolves in the coming decades.
All right, the folks at the home office are chiming in. They've got some questions. I like this one. This one I'm assuming is from Trevor Sumption. He wants to know if anyone has eaten one.
That is also a very frequent question. So it's funny you mentioned that. So when they first invaded, that is probably one of the first control methods they tried. There's a very famous picture that is very well known in our office of someone with they have it on some sort of spear or fork above a pot, where you can tell, and they have a kind of disgusted look on their face, because as the story goes, for any accounts of people that have tried to cook them, it's just quite frankly disgusting. So by all accounts, the meat is gray, mushy, just otherwise visually and taste-wise just unappetizing. We've had people that have tried to smoke them. People have tried to fry them, and they still don't taste good. And I mean, in my opinion, if you're frying it and it still doesn't taste good, then something's wrong. So yes, they have tried to eat them, but unfortunately, they are not really seen as a good species to eat. And I think on top of that, even if they were edible, you wouldn't want to eat the ones in the Great Lakes, specifically because they have high concentrations of heavy metals. So some of these apex predators that they're feeding on, like lake trout, they are accumulating heavy metals, through the smaller fish, the fish lower down in the food chain that they're eating. And when the sea lampreys are drinking those apex predators' blood and bodily fluids, they're getting just heavy metal, almost all of the heavy metals straight to their system. So they have high concentrations of heavy metals, so you wouldn't even really be able to eat them even if you wanted to. I will say that not here in the Great Lakes, but over in the Atlantic Ocean, specifically in Europe, so on the eastern coast of the Atlantic Ocean, lampreys are considered quite a delicacy. So they are oftentimes, so if you went in a restaurant and they had, for example, they have fish that are market price. Sea lampreys are those kind of fish. I believe one of the delicacies, I can't remember which country it was, but one of the delicacies is sea lampreys in a stew of their own blood. Or something along those lines. I know there is also the Queen of England also makes a ceremonial lamprey pie every so often. And so I think it was back in 2015 or the early 2010s where we actually did send some lampreys over to England for the Queen and her lamprey pie. So not eaten here in the Great Lakes and don't want to be eaten here in the Great Lakes, but if you really wanted to, you could go over to Europe to see if you can find yourself some lampreys.
All right, I think I'll pass on that one. But one of the other things that I hear, I talk to some anglers in Lake Erie, and one guy that I've talked to in particular, his theory about the effectiveness of worms on Lake Erie is that walleyes are used to eating sea lampreys, and a worm looks like a nightcrawler looks like a sea lamprey. Are there fish that actually eat sea lampreys out there?
So if fish did prey on sea lampreys, it would be in that larval stage where they are small and easily susceptible. As far as we understand, there isn't an established predator-prey relationship where fish are feeding on lamprey larvae so much that they're actually affecting the population. I mean, that's not to say that it couldn't happen. I would totally expect it to happen if, a fish is right by some larvae swimming out of their burrow. But as far as we understand and as far as we've seen, there is no established predator-prey relationship. I mean, you will have, after we do these lampricide treatments and, on some of these larger treatments, we're killing lampreys on the magnitudes of millions, hundreds of thousands. And so they'll be floating all around the river. And then you'll see, fish come and eat those dead lamprey, or, for example, seagulls will come down and eat them. So they will feed on them opportunistically, but as far as an established predator-prey relationship, it's not something that we've seen.
All right, Ross, how about you talked about the numbers, how many sea lampreys that you're killing with these efforts? What do you think would happen if we just scrapped the whole thing and decided not to do it? How fast would they be able to kind of take over the lakes again?
Yeah, absolutely. So that's a great question. So one thing that if we did stop, say, so for example, when we did in 2020, if you're not able to go out and treat, you're not going to see the effects immediately. So the next year, because of that larval stage, as I mentioned, they're going to be in that larval stage for anywhere from 3 to 5 years. So you're going to see, it'll probably be about 3 or 4 years before you see a significant uptick in the population. But we have done that previously. I believe it was the 90s where for whatever reason we were experimenting with stopping sea lamprey control, and then within I think it was less than 10 years we had seen a substantial uptick in lake trout wounding. You saw a decrease in the lake trout population. Excuse me. So so you wouldn't see it immediately, but 4 or 5 years down the line, you would definitely see the effects. You'd see more scars on your fish that you're catching. You see decreased fish population numbers. And so even though it's not something you'd see an immediate effect of, it's something that needs to be ongoing. So even though we've reduced the sea lamprey populations by over 90% compared to the historic highs in the 1940s and 1950s, the sea lampreys are still out there. As I mentioned, they are so widespread throughout the Great Lakes that we are sending control teams out there every single year to treat the most infected streams. And so if we stop that, I mean, the effects on the Great Lakes fishery would be enormous. As I mentioned, when they first invaded, they almost wiped out lake trout from the whole entire Great Lakes. The Great Lakes fishery in general was nearly destroyed thanks to lampreys, as well as other factors such as overfishing, habitat destruction, and pollution. But now, I mean, thanks to, in part, to sea lamprey control, the Great Lakes fishery is valued at over $7 billion. So even though you wouldn't see that immediate effect on the Great Lakes fishery, you would see it in 4 or 5 years. And I think you'd quickly find out that you need to continue lamprey control.
All right, here's one from a guy that's always on the show, always asking questions, Rick Mansell. He'd like to know if they prey on fish in the entire water column, how deep can they go?
Yeah, so that's a great question. So most of the time, they're going to be hanging out in the deeper parts of the water. So they prefer the colder, dark parts of the Great Lakes. And what's interesting about that is they will actually change their color of their bodies depending on what type or what stage of their life cycle they're in. So when they're in that predatory phase, their juvenile and parasitic phase, when they're out in the lakes, down in the deeper parts of the water, they're actually going to be almost black, dark gray. But then once it's time to spawn, they're hanging out in the shallower parts of the water, the silty, muddy streams, they're actually going to turn into a brownish yellow. But yeah, so and that's another thing too. So we mentioned, sea lampreys not attacking humans. That's part of the reason too. And if you're diving down into 100, 200 feet of water, you're going to see lampreys, but lampreys are not going to be swimming near the beach. They're not going to be like sharks coming up to you. So sea lampreys are only hanging out in the deeper parts of the water column.
Are you saying there's sharks in the Great Lakes?
Not that we know of yet. Maybe there's a Loch Ness monster, a megalodon sort of thing, but not that we've seen.
All right, didn't want to break any news today. All right. What should an angler do if they catch a fish with a sea lamprey attached?
Yeah, great question. So I think the first thing is to ensure that it is in fact a sea lamprey. So what a lot of people fail to realize is that in addition to the sea lamprey, there are actually 4 native species of sea lampreys in the Great Lakes. And so they're pretty easy to tell apart because the sea lamprey is going to be significantly larger than most of your native species. In fact, only 2 of the 4 native species are going to be parasitic or attaching to fish and drinking their blood. So once you confirm that it's a sea lamprey, so if you're looking at, again, as I mentioned earlier, somewhere on the size of a foot and a half, that's going to be a sea lamprey. And so once you confirm that, just cut its head off. Do not throw it back. Cut its head off and throw it back in the water. Chop it up, and doesn't matter how you do it. Just make sure it doesn't go back in the water alive.
All right. How about the fish itself? Is the meat safe to eat if we catch one that has a sea lamprey connected?
Yeah, great question. Yeah, it is absolutely safe to eat. People prefer to, cut around the scar so you don't necessarily see that on a fillet that you're whipping up. But yeah, it is totally safe to eat.
Ross, what do you see as kind of the future of the sea lamprey in the Great Lakes and how we'll deal with it? What do you see going into the future?
So I as I mentioned, I think it's hard to say, but as I mentioned, we're investing substantial amounts of money into alternative sea lamprey controls. So those pheromones are, I think, definitely something that it could prove to be very effective. So sea lampreys are primarily smelling organisms. So their nasal organ is magnitudes of times larger than their brain. So they make a significant amount of their decisions using their nasal organ and smells. And so if we can really exploit that, I could see that as being a key element of really reducing their populations. We're also looking at applying alternative control methods in specific situations. So, for example, what we call our sterilized male program. So, as I mentioned, sea lampreys will spawn and die. And so, with the sterile male program, what we do is we will catch those sea lampreys, catch male sea lampreys in traps, take them out to our lab and sterilize them, and then put them back in the rivers to go and spawn with female sea lamprey. So both of the sea lampreys will spawn and die, but they won't actually produce any fertile offspring. So that's one thing we're looking at. Other control methods that have been investigated and are being investigated is trapping the juveniles that are going out into the lakes. So seeing if we can get them after they emerge from their larval stage and going and swimming out into the lakes. And there are other more far-fetched control methods that people have discussed. So, for example, like what if we did genetic controls? So what if we went and did something with the sea lamprey's DNA and did something where that through the genetics, and if we implanted this gene that then got passed down into future populations, could there be a way that we could do that and have the sea lampreys themselves drive themselves into extinction? So the options are really wide across the board, but I'd say the pheromones and the sterile male program are two that particularly come to mind that a substantial amount of research is going into and are proving feasible, at least at the moment. Of course, this is still in the research phase, so even though it is looks good in an experiment that's more or less a controlled setting, you're not necessarily going to see as much success, or might not necessarily see as much success as you would out in the real world compared to what you might find in an experiment. So it very well could be that we find something, say, for example, the sterilized male, where it works great in this controlled setting, but once it is put on a wider scale, it might not be feasible. It might not work as well. So that will be something to keep an eye on. But yeah, it'll be very interesting. And I think one other thing one other thing that we've discussed is, thinking about, well, will we ever completely eliminate sea lampreys from the Great Lakes? And at least given our current control methods, it's hard to say that we ever will. Right now we view sea lamprey control as more of managing the population to help promote a healthy and sustainable Great Lakes fishery, which, as I mentioned, is valued at over $7 billion. So we are successfully doing. But because the Great Lakes are so large, there are so many sea lamprey producing tributaries, because the sea lampreys are so pervasive when they go to spawn. So when a female sea lamprey goes to spawn, she'll produce up to 100,000 eggs. So just a brand new spawning population can easily be established by just a pair of sea lampreys. So primarily due to their life history and due to the size of the Great Lakes Basin, given our current control methods, it's hard to see that we would actually completely eliminate them from the Great Lakes. But as I mentioned, the management of it is going extremely well, and we're helping to promote a healthy and sustainable Great Lakes fishery.
Ross, it's great having you on. Really fascinating things that we were talking about today, and the audience was certainly very interested in what we were talking about. Is there anything that you wanted to talk about today that I didn't ask you?
I'd say one cool thing that I think is super neat, and primarily because this is the work that I did before I came on, is or before I came into my current position as a communications associate. I worked with a former colleague of mine who went and did what we called a big oral history project. So essentially what he did is, this was a multi-year project where he went around and interviewed anybody that had any experience with the sea lamprey story. So people that were in those coastal communities, commercial fishermen and fishing families, people in the early days of the Fish and Wildlife Service and Fisheries and Oceans and the control program. So what he did is he went around and essentially tried to get firsthand stories from all these different stakeholders of the sea lamprey story. And he eventually went on to go and write a book. So his name is Dr. Corey Brandt. And so he wrote this book, Great Lakes Sea Lamprey, the 70-Year War on a Biological Invader. And so that was just a super, super interesting book. And one anecdote I like to talk about is how they discovered this TFM, or lampricide. And so back in the day, as I mentioned, once the sea lampreys invaded, people were extremely desperate to find a control method. Fishing was an extremely important economic source of income for many people in the region. And so people were desperate to find a control method. And so what they were doing to help address and find a control method is there was a research station that actually still exists today up in Millersburg, Michigan, just southeast of the bridge, a little bit south of Sheboygan, Michigan. And so at this research station, they were working day in and day out. And essentially what they were doing is they were looking for this chemical, the selective chemical that would target and kill lampreys. And so what they would do is they would set up what we call bioassays. And so they would take a jar, fill it up with water, and then put in 2 native species. So then put in a bluegill and I believe some sort of trout species, as well as a sea lamprey larvae. So they put those 3 in there, and then essentially they put out a call to any and every company. So chemical companies, anybody that was making any sort of chemical, they put a call out and just said, please send us a chemical. We are trying to find a selective toxicant. And so it wasn't, they would, do these chemicals. They wouldn't even know what was in them. There's stories, one of the oral history interviews that my former colleague Corey conducted was with the actual chemist who weighed some of these chemicals as they came in. And so one famous story he always talked about was how there was one particular chemical where he opened it up, and as soon as he opened it, it immediately evaporated. So, you had, who knows what kind of chemicals these were, but they would take these chemicals, pour a little bit into that bioassay jar and just see what would happen. Give it 24, 48 hours, see what would happen. And it wasn't until number 5,209 until they actually found TFM. So it was a really remarkable story to hear in Corey Brandt's book. And it was just super interesting to hear just how desperate and how dedicated some of these early control personnel were to helping to save the Great Lakes fishery.
And that's how they found Formula 409 too. It was the 409th thing they tried. So we'll call this stuff Formula 5209 and call it a winner. Well, Ross, really appreciate you coming on. And if people want to know more about sea lampreys and everything else that the Great Lakes Fishery Commission has got going on, you can go to their website. It's glfc.org. And you've also got a Facebook page and all those other things that people are looking. But we really appreciate you coming on. It was fascinating talking to you, and definitely a subject that people are interested in. So thank you very much for your time.
Yeah, thanks so much for having me on. This was so much fun.